Okay, so present value. This is what I do not have up on the board, and I will, okay? Often people want to know how much money to invest now in order to get a certain amount of money in the future. Makes sense? Just use the rearranged compound interest formula. Okay, so we were talking about this now, right? How much should I start investing now so that in the future I can have certain. So Adele's parents would like to have 150,000 when they retire in 9 years. How much should they invest today at an interest rate of 6% per annum compounded annually? So we have this equation. So basically we're the same thing. Our future value in this case is $150,000. Our interest rate is 0.06% divided by, and compounded annually, so it's divided by 1. So it's just going to end up being 0.06. And n is 9 years times 1, because it's compounded once a year, so our answer is 9. So the only thing that changes here is the equation. So now our present value is equal to 150,000, 1 plus the 0.06, and our exponent now is a negative 9. Okay, because that's actually, we know this now, it creates the 1 over, so it's actually fractional. But you don't need to do that, you just need to recognize that you're now calculating present value based on what you want in the future. Recognize that you're going to use your present value formula and then just plug it in. So 150,000
So the only thing you changed was
is the exponent. Yeah. Yeah. So I have that we should invest present value $88,000, $784.77. So in 9 years to have 150,000, you need to invest $88,784.77 today. Now, are people only going to invest and want the money 9 years from now? No, it's what Steven said, right? I'm investing now for 20, 30 years from now, okay? That's why you need to invest early.
So you don't have to invest
as much. The smaller you invest now, okay? So next one. Sue wants to give her niece $8,000 to help her pay for college. How much should she invest today at an interest rate of 4.5% per annum, compounded monthly, to give her the money in 24 months? Okay, so again, our future value is 8,000. Our interest is 0.045 divided by, it is compounded monthly, 12. Okay, so 0.045 divided by 12 gives me 0.00375. And then n is already in months, so we just have to do 24. It's no big deal, it's already in the month format. So I have present value is now equal to 8,000, 1 plus 0.00375 to the exponent negative 24.
So all your,
Yeah, so just your exponent in this equation is changing. And your multiplier is now your value you want in the future instead of your present, okay? Nope. You just need to be able to differentiate between the two. And don't forget your negative exponent. So I have, hopefully this is right. Let me check one time if it looks small. Yeah, so I have her present value of what, because it's only 24 months, excuse me. $7,312.68 is how much she needs to invest. Now, because she wants the money in 24 months, so that's 2 years, right?
Yeah.
Okay, so you see why you need to invest early, right? Okay, which formula would you use for which situation, okay? So, at the end of 5 years, after being charged interest at 3% compounded monthly, Simon has paid $10,135.11. How much did he originally invest? So we know in the future how much he has, right? but we want to know how much he originally invested. Which one would you use? Present value. Okay. So Jonathan borrows $9,000 from a financial institution. Oh, sorry, I'll put this. Okay. Jonathan borrows $9,000 from a financial institution for the purchase of a used car. The term of the loan requires Jonathan to pay interest at 4% per year, compounded semi-annually, and repay the total amount at the end of the 2 years. Okay, careful. He originally gets $9,000, but in 2 years they want to know how much he's going to have to pay in 2 years. So would it be PV or FV? FB, we want to know how much he owes in the future, okay? Because he gets $9,000 now. Martin was 5 years old. Her parents invested $12,000 for her in a plan that earned 6%, compounded semi-annually. How much will the investment be worth when she turns 12? Careful. What did you say? Okay. At the present, right? When she was 5, they invested $12,000. In the future, 12 years from now, they want to know how much she'll earn. So what are you calculating?
Oh, I got my things mixed up, that's why.
We're calculating the future value, right?
Compounded semi-annually for how many years, right?
12. You don't need to actually calculate. We just want to identify, right? Okay, Lucy received $4,300 as a graduation gift. She wants to invest this money and some of her savings into a savings plan that offers 4.8% per year compounded quarterly. She would like $20,000 after 20 years. How much should she invest today? Yeah, because how much should present value? Yeah. Because in the future she wants $20,000. Okay, so that's it for this lesson, guys. You can go on to that practice now.